grade 9 science teacher. I'm here to help you be a Sci fanatic. Here are the objectives for today's lesson. Differentiate empirical and molecular formulas and calculate the empirical and molecular formula of a given compound. Let's have a quick recall about our past lessons.
Now let's try to find the molar mass of the following compounds. First one is carbon dioxide and H2O or water. You can pause the video while doing your computation.
For those who are having a hard time solving for the molar mass, this is how you will do it. First is to list down all the elements present in the compound. And the elements present in the compound are carbon and oxygen. Next, count the number of atoms in each element. Next, get the atomic mass or weight using the periodic table of elements. Round it up to the whole number. Get the product of the number of atoms and its atomic mass. Then, sum up all the products. Then you will get the molar mass. So, the answer is 44 AMU or 44 atomic mass unit. The unit AMU can be replaced by grams per mole. So, the molar mass of carbon dioxide is 44 grams per mole. Now let's try to find the molar mass of H2O or water. First is to list down all the elements present in the compound, and these are hydrogen and oxygen. Next is to identify the number of atoms in the compound. Next is to get the atomic weight or the atomic mass of the element. Then, multiply the number of atoms to each atomic weight. Sum up all the masses and then get the product. And the answer is 18 AMU or 18 grams per mole. So, the molar mass of carbon dioxide is 44 grams per mole, and for water, we have 18 grams per mole. I hope you got it all correct. Now let's try to find the percent composition of each element in the compound carbon dioxide or CO2. In determining the percentage composition of a compound, let us solve first for the molar mass. Earlier, we found out that the molar mass of carbon dioxide is 44 grams per mole. Then, divide the actual mass of the element with the computed molar mass of the compound. Then, multiply it by 100%. Do this for all the elements present. To check your answer is correct, it should sum up to or near 100%. Now let's visualize the percentage composition of carbon and oxygen. In chemistry, we use different kinds of chemical formulas in indicating the elements and their proportions in the compound. So it is a must that we should know how to differentiate one formula from the other. For today's lesson, we will focus on how to get the empirical and molecular formulas. Let's now differentiate empirical formula from molecular formula. An empirical formula shows the simplest formula of a compound. It is also the smallest whole number ratio of the elements found in the compound. While the molecular formula gives the exact ratio of the elements involved in the compound. Now, let's determine how empirical and molecular formula of a compound can be calculated given its percentage composition. Now, let's have this sample problem. Determine the empirical and molecular formula of a compound having a molar mass of 294 grams per mole, and the following percentages composition are 26.53% for potassium, 35.37% for chromium, and 38.10% oxygen. First step is convert the percent composition to an actual mass. The given data is in percent. Percent means part per 100. Assume that the compound is 100 grams. So you can just remove the percent sign and change it to grams. So 26.53% of potassium will become 26.53 grams. So on for chromium, and the same with oxygen. For our step 2, I want you to convert the mass to moles of each element by dividing its atomic mass by its molar mass as given by the formula. So again, atomic mass divided by the molar mass. So as shown here in my computation, I just divide the atomic mass of potassium, chromium, and oxygen with its molar mass. And then, I have now its mole equivalent. Take note of the smallest mole value, and that is 0.680256 mole. For step 3, find the whole number ratio of the moles of the different elements by dividing all the moles of the element present by the smallest number of moles. So I have here, take note that 1.00, 1.00, 3.50. Take note that the only decimal part in the number of the atoms is 0.50. To convert the decimal part to a positive integer, we use the multiplier 2 to make it a whole number. So, when we multiply these values by 2, it will become 2, 2, and 7. These numbers will become the subscript, and then the empirical formula would be K2 Cr2O7. For step 4, to get the molecular mass, compute first for the empirical molar mass. In step 3, we have the empirical formula. You will just get its empirical molar mass. And the empirical molar mass is 294 grams per mole. Step 5, divide the actual molar mass by the empirical mass. The molar mass is already given, and your empirical molar mass, that's the one that you compute in step 4. So cancel out the common units, and the answer will become 1. So this one will be the ratio, which will be multiplied to the empirical formula. Step 6, multiply the ratio with the subscript or subscripts of the empirical formula. Our ratio is 1, so you just multiply 2 times 1, that's 2. 2 times 1 is 2. 7 times 1 is 7. And then, this formula is now your molecular formula. After discussing the different steps to get empirical and the molecular formula, I hope class everything is clear. But if it is not clear, you can go back again to our video. Now, I think we're all ready for our activities. Again, put on our thinking cap. You can pause the video while doing your calculations. Good luck! For our first activity, Who Am I?, you will just classify the following formulas as to empirical or molecular formulas. Again, Pause the video while answering this activity. And these are the correct answers for activity number 1. Guys, check out your answers if you got a perfect score for this activity. For our activity 2, you will now calculate the empirical and molecular formula from percentage composition. So the sample problem is, nowadays, vitamin C or ascorbic acid is important in boosting our immune system and has a molar mass of 176 grams per mole. The composition is 40.9% for carbon, 4.58% for hydrogen, and 54.52% for oxygen. Again, compute for the empirical and molecular formula. Check out the answers for the empirical formula. It should be C3H4O3. For our molecular formula, C6H8O6. A bit confused? Still not ready? Let's summarize. To get the empirical formula for the first step, if the given is in percent composition, assume a 100-gram sample, then convert it to grams. For step 2, use the atomic masses to convert grams to moles. Divide the moles of each element by the smallest mole fraction. Then, the results from step 3 should be a whole number. If not, make it so by multiplying a common factor. Next is how to determine the molecular formula. First is find the empirical formula. Next is to find the molar mass of the empirical formula. Third is to divide the molar mass of the compound by the molar mass of the empirical formula. And the quotient will be your multiplication factor. I hope we achieved our objectives for the day. Thanks for watching. I hope you have a fantastic day.